Okay, so this is from TSSM. It's exam 1, 2023, question number 8. It involves some general rules that look pretty awful, but integration by recognition. And it comes from a probability question. So show by differentiation. So I need to take the derivative. They're even telling me what to do. That an antiderivative of this is this, therefore the derivative of this bit must be that. So I need to do d dx of x to the n log by c of x plus c, and I can see a product rule, u equals e to the x, x to the n, u dash will equal n x to the n minus 1, and v equals log by c of x, which means v dash equals 1 on x. And to do my cross multiply, it's going to be this times this, so x to the n times 1 on x plus n x to the n minus 1 times log by c of x gives me x to the n minus 1 because this will combine and the x will have 1 less x because it cancels to give you n minus 1 of them, plus n x to the n minus 1 log by c of x. And what form do I have to put it in? They take out a common factor, so equals x to the n minus 1, 1 plus n log by c of x is what I need to show in part A. Beautiful. Hence or otherwise, find the value of A such that it's a probability density function. So if you integrate all of this over the full domain, therefore the area should equal 1. So 1 should equal the integral, bring the A out, of 0 to 1 of x squared log by c of x dx. So what can I do with this over here? If I was to anti-differentiate this with respect to x and this with respect to x, then I would end up with the inside x to the n log by c of x equals integral of x to the n minus 1 plus, plus the integral of n x to the n minus 1 log by c of x dx. And this equals x to the n over n. So I can comfortably say, rewriting this on the left-hand side, the integral of n x to the n minus 1 dx log by c of x dx equals x to the n log by c of x minus, because that would go to the other side and become a minus, x to the n on n, which means the integral of x to the n minus 1 log by c of x dx equals 1 on n, x to the n log by c of x, minus 1 on n squared x to the n, as being the expression that would represent this integral. And this integral here that I'm looking for is this when n equals 3. So 1 equals a times, when that equals 3, I'll end up with 1/3 x to the 3 log by c of x minus 1/9 x to the to the 3 from 0 to 1. 1 equals a times, that bracket's not there. So 1/3 times 1 log by c of 1 minus 1/9 times 1 minus 0 plus 0. So 1 equals a times negative 1/9. A equals negative 9. And to do part C, I need to determine the expected value. The expected value will be this times another x. So the expected value will be the integral from 0 to 1 of x times p of x dx. And that expected value will be integral of 0 to 1. A is negative 9 x cubed log base e of x dx. Because p of x is x squared log base e of x. We're multiplying by another. So to use my general rule, and my general rule was this general rule, I've got x cubed, so n must equal 4. And that's going to equal negative 9, 1 on 4, x to the power of 4, log base e of x, minus 1 on 16, x to the 4, from 0 to 1, which would be negative 9, 1/4, 1 log base e of 1, minus 1/16 times 1, minus 0 plus 0, gives me minus 9 on minus 16, gives me 9 on 16, will be the expected value.